Hello, welcome to section 5.1. We're talking about adding and subtracting polynomials. So very exciting. So first we're going to identify the different types, which is connected to their degree. And then we're going to add and subtract monomials and add and subtract polynomials, which are just monomials with plus and minus signs in them. And then evaluate for a given value. So first of all, I'm pretty sure you've heard of the word term, where it's either a constant or a product of a constant and a variable. So, for example, some terms or some monomials are 8, negative 2x squared, 4y cubed, 11z to the power 7. Another example of a term or a monomial where you have 2x y, and then you can have a multiple ones. Okay, so in the book, it defines monomial as ax to the m, but in other books, it's called, you can have multiple variables, which is fine, but for the most part, we're going to do single, unless we, property of exponents and reducing and stuff like that. So we'll get into that soon enough. All you need to know is that there's no plus or minus signs before or after. It's just one term, okay, or one monomial. Mono meaning one, Okay, so a polynomial, it's basically like the umbrella term. So polynomial, it's the largest term that includes monomials, which is just, monomials, which is one term, binomials, which, as you can guess, it's two terms, So here you have one and one, and they're always separated by a plus or minus. Trinomial, 3x squared plus 5x plus 7. So you see how it's 1, 2, 3 terms. Okay, so the number of terms can affect the name. So we only really use monomial, binomial, trinomial. And then after that, any more terms after that, we just say polynomial, that's just the way it goes. Okay, so now that we've defined those terms, let's talk about a degree. So the degree of a term is the sum of the exponents of its variables. So for a single term, right? So for a single term. Okay, so a constant, remember that a constant is just like 5, 7, whatever. It's just numbers, okay? The degree of that is 0 because there's no variable, okay? And the degree of a polynomial is you look at all the terms and the one with the highest degree, that's the degree of the polynomial. So let's say, for instance, here are some examples of a monomials and their different degrees. So constant, the degree is 0. Here we have 8y squared. The exponent is 2, so it's degree 2. Here we have 9x cubed y to the 5th, so 3 plus 5 is equal to 8, so the degree is 8. And then negative 13a, the exponent is 1, so that's a degree of 1. Now, for a binomial, so let's say we have a plus 7. A is first degree, 7 is 0 degree, so the degree of the entire binomial is 1. Here we have 4b squared minus 5b. This is degree 2. This part is degree 2. This part is degree 1. So the entire thing will be degree 2 and so on, right? So ultimately, in general, polynomials, trinomial is the same thing. You can tell the degrees of each one, and then the degree of the polynomial is the highest one. So let's say here, b plus 1, this is the highest, so it's degree 1. This one right here has the highest exponent, so that's degree 2. And then here, 4x to the 4th, that's the highest, so the degree of this polynomial is 4. Okay, so let's make sure, let's practice. So determine whether each one is a monomial, binomial, trinomial, or some other polynomial. Remember, you can always hit pause and try these out, and then check and see with me if you're right. It's actually super highly recommended because it's good to go through that process of at least trying it and being wrong. It's so helpful to do that because it's better to make the mistakes now than when we take the exam. Okay, so that's enough of that. So here for the first one, did you guys say trinomial? Yes, because there's 3, right? This one is a monomial. There's no other pluses or minuses. This one, 1, 2, 3, 4, 5 terms, we're just going to call it polynomial. Poly meaning many. 2 terms, binomial. 1 term is a monomial. Okay, if we wanted to say the degrees, just for funsies, A is degree 2, B is degree 6, right? Because 4 plus 2. C is degree 5. D would be a binomial of degree 3 or of 3rd degree. And then E would be a monomial of the 1st degree or degree 1. Okay, so just a couple more, I guess, here. We have a monomial degree 1. Here is a polynomial. What degree is it? It's 3. For C, we have a trinomial of degree 2 or 2nd degree. This one is a binomial of the 2nd degree, right? 2nd degree. And then this one is a monomial 6th degree, right? Degree 6. Okie dokie. So to add or subtract monomials, they have to be what we call like terms. What does it mean to be like terms? That means you have the same variables with the same exponents, and that's it. They have to be exactly the same in order for you to add or subtract, okay? So so let's see here. Here we have 25y squared plus 15y squared. So sometimes if they're alike terms, I like to think of them, or I like to say them as apples. So like if you have 25 apples plus 15 apples together, that's going to be 40 apples, but instead of apples, it's y squared. Okay. You know, so really you just look at the coefficients and deal with those. So 12 plus 9, right? 12q squared plus 9q squared becomes 21q squared. Negative 15c squared plus 8c squared, that becomes negative 7c squared. And then 16p minus a negative 7p, that becomes a plus. So then that together is 23p. Okay, let's do some super fun examples. Okay, so let's simplify. So another thing that you can think of here is you can only combine like terms, right? So I can only combine the ones that have a c squared. So this would be negative 5c squared plus 7d squared, and that's it. I can't do any more than that, so you leave as is. Here I have 8y squared minus 3y squared, that's 5y squared, plus 3z squared, and we're done because I can't combine those two. One has a y and one has a z. Okay, so here we have u squared v plus 5u squared minus 3v squared. So we can't do anything here. So you just leave it as is because I can't combine any of these terms. None of these terms are alike. Same thing here, right? pq squared minus 6p minus 5q squared. I can't combine any of these, so leave it as is, okay? All right, now what about polynomials? Okay, so if you want to do adding and subtracting polynomials, it's the same thing. It's just you add all the common like terms and that's it. So here I have 7y plus 4y squared, so that becomes 11y squared. Then I have negative 2y minus 8y, or minus 2y, so that becomes negative 10y. So then here I have a 9 plus a negative 7 or plus minus 7. That becomes positive 2, and that's it. Okay. Now, when you find the difference, you just have to distribute the negative, so don't forget that. So 9y squared minus 7w plus 5 minus 2w squared plus 4. So like terms, it really helps to underline or circle or whatever, you know. So in this case, there is no other w, so I just write that down here. Then I have 5 plus 4, and that's plus 9. So usually the standard order is to write it from highest exponent to lowest, with the constant being at the end on the right. But, you know, it's not wrong if you write it a different way, but that's just usually the general way how to do it. Okay, so now it says here subtract p squared plus 10 pq minus 2q squared from p squared plus q squared. So that means that p squared plus q squared comes first, and we're subtracting the other thing from it. Okay, so like that. So now let's distribute this negative. Okay, so we have p squared plus q squared minus p squared minus 10pq plus, because I'm distributing that negative, 2q squared. Okay, so for the p squareds, they actually cancel out. So that's nice. Now, what about the q squared? So I have a q squared here and I have a 2q squared here. So together it's going to be 3q squared. And then what's left is this negative, or this minus 10pq. Okay. All right. And then finding the sum. So let's combine like terms, right? Since you're adding and there's nothing in front of the parentheses, you might as well imagine it being without the parentheses. So 4u squared. Now here I have a negative 6uv and I have a 2uv, so minus 4uv. And then what's left is this 5v squared positive, okay? And that's it. It's really not that bad. Okay, let's do one more that might seem a little bit complicated, but it's not. All it is just underlining the like terms, okay? So I'm going to distribute this negative, though, of course, because we don't want to make, whenever you have a negative in front of a parenthesis, it's just best to write another line, distribute a negative, don't be lazy, write that extra line, it's fine. So we have a cubed minus a squared b minus ab squared minus b cubed plus, right, there's no negative in front of here, so plus a squared b plus ab squared. Okay, so a cubed. Is there any other a cubes? Nope, so I'm done with that guy. How about negative a squared b? Oh, I have another a squared b right there, but they cancel out, so that's good. So now I have a negative ab squared. Oh, here's a positive ab squared. Oh, also canceling each other out. Then what's left is that negative b cubed, and that's it. Okay, so something that might seem so super complicated is actually not that complicated. With practice, my friends, you'll get there. Okay, so a polynomial function is a function whose range values are defined by a polynomial. That's fine. Or just, just think of it as the output. This is basically like you have a function f of x. So what does that mean? So you can kind of think of a function as a little function machine where the input goes in and then f tells you what to do to it, and then the output is f applied at that x, right? So basically this function f of x says, hey, whatever input you insert here, square it, multiply by 5, then subtract it by 8 times that input plus 4. So this is basically my input, okay? So So f of 4, we say f of 4. Now, this is not multiplication, not times. Even though because sometimes you can use parentheses as a multiplication. This is a notation. This is like a name. This is just saying like the function f of 4, right? So evaluated at 4. So technically that's saying, this function, this specific value of the function evaluated at x equal 4, okay? And that's going to be, so anytime you see an x, you just put a 4. So 5 times 4 squared minus 8 times 4 plus 4. And then that becomes 16 times 5, which is 80 today, minus 32 plus 4. So then we have 80 minus 32, which is 48 plus 4, so that's 52. Okay, and then b, f of negative 2. So f of negative 2 is just going to be 5 times negative 2 squared minus 8 times negative 2 plus 4. So then that's going to equal 5 times 4, which is 20, plus 16 plus 4. So then final answer 40. So f of negative 2 is 40. And then finally f of 0. So you get 5 times 0 squared minus 8 times 0 plus 4. So this becomes 0, this becomes 0, so your final answer is 4. So f of 0 equals 4. Okay, cool. So let's do a cute little word problem here. The polynomial function h of t is equal to negative t squared plus 250. It gives the height of a ball t seconds after it's dropped from a 250-foot tall building. Find the height after t equals 2 seconds. So if you have this, basically, now, I don't know if you guys ever noticed, this isn't really like, everyday conversation, but hey, who knows? If you've ever noticed when you throw a ball, it behaves like a parabola. It kind of has this like up, down. And we know that because it's gravity's working on it. So even if you throw straight up, it comes back down because gravity's pulling it down. So you can describe, trajectories of things that are thrown, objects by with parabolas or with quadratic functions. It's really cool because we use this in like so many different ways, so many applications. Anyway, so find the height after t equals 2. So what that means, it's asking you, what is the function evaluated at 2? Because notice that t is the input. Okay, so that's all that is. So then just plug in a 2 and solve and do your thing. So what's negative 16 times 4? That's going to be negative 64, yeah? So that's negative 64 plus 250. So what is negative 64 plus 250? So negative 64 plus 250. So let's see here. In other words, what's 250 minus 64? That's the same thing, 186. So h of 2. So the height of the ball after 2 seconds is 186 feet. I'm thinking, yes. All right. Okay, let's continue. Adding and subtracting polynomial functions. So basically, when you're adding, it's just the notation you have to get familiar with. Other than that, super easy. You got this. It's not bad. We've been doing it from day one. We've been just been going through and we just haven't actually written down f of x plus g of x, right? So when you see this notation, so again, it's just symbols telling you what to do. So just take f of x and add it to g of x. So add them together. Okay, so then here we have f of x plus g of x. So A, we have f of x plus g of x. So you just write down, this is f of x and this is g of x. So f plus g of x is equal to 3x squared minus 5x plus 7 plus, and then g of x is x squared minus 4x minus 3. So then like terms, 4x squared minus 9x plus 4, right? Like terms. Okay, see how we're becoming pros at this? All right, then B, f plus g evaluated at 3. So I'm actually going to put that here because we already did f plus g, but fine, I'll just, we'll do it the other way. So there's 2 ways you could do this, okay? So 2 ways. What's the 2 ways? First of all, you could realize that I've already figured out what f plus g is. It's right here, 4x squared. And you plug in 3 into that, okay? The other way, if you hadn't figured it out, f plus g evaluated at 3 is the same thing as f of 3 plus g of 3. So f of 3 is 3 times 3 squared minus 5 times 3 plus 7, and then plus, and then g of 3 is going to be 3 squared minus 4 times 3 minus 3. Okay, so combining like terms, we have 3 times 9, so that's 27 minus 15 plus 7 plus 9 minus 12 minus 3. So then here we have, let's see, what can we do? So 27, I'm just going to go through it. So this is 12. I'm going to bunch them together. Plus 7 plus 9. If I do these 2 together, that's plus 16. And if I do these 2 together, that's minus 15. These 2 together become 1. So my total answer is 13. Okay. Could we have just plugged in 3 here? Yes. That would have been 3 times 3, which is 9, minus 27, because 9 times 3 is 27 plus 4. So then that would give you what? 36 minus 27, which is 9, plus 4, which is 13. See how much shorter that was? So either way, we got 13. Okay, so that's A and B. Sorry. What if you want to subtract? Yeah, that's the same thing, except that you're now doing minus. So 3x squared minus 5x plus 7 minus, and then we have g of x, which is x squared minus 4x minus 3. So then distribute this, and you get 3x squared minus 5x plus 7 minus x squared plus 4x plus 3, distributing the negative. Combining like terms, then that's going to become 2x squared minus x. And then 7 plus 3 is 10 today, okay? So that's for C. But then for D, let's just plug in -2 because we don't have enough space. F minus G of -2, that's going to equal, I'm going to put -2 in here, 2 times -2 squared minus a -2 plus 10. So then that's going to equal 4 times 2 is 8. This becomes a plus 4. So then that's, plus 2, sorry, plus 2 plus 10. So then that's just going to be a total of 20. Okay. All right. So I think we've already done enough of these. Let's do a little bit more. Evaluating a polynomial for a different value, for a value. So same thing here, except that now it's actually going to be easier. You know, that's funny. We should have done the other one before. So evaluate this when x is equal to 4, x is equal to -2, and x is equal to 0. So we have at x equals 4, 5 times 4 squared minus 8 times 4 plus 4. So then that becomes 16 times 2, 5 times 16 minus 32 plus 4. This is equal to what? 80 minus 32 plus 4. And that's going to be 80 minus 32. That's 48 plus 4. And that's 52. Okay. Sorry about that. I feel like we did these already, but maybe I'm crazy. I am crazy. I don't know. 5 times -2 squared minus 8 times -2 plus 4. And then I have here 5 times -2 squared is positive 4. So that becomes 20 plus 16. Negative times a negative is a positive plus 4. And then this is 40. I'm pretty sure we did these already, but whatever. I'm sorry if we did. 5 times 0 squared minus 8 times 0 plus 4. These are going to cancel and you get 4. Yeah, I'm pretty sure we did this. Okay, so if we did these already, you guys can practice these further. I'll go ahead and work these ones out because they're just here, just asking to be worked out. Okay, so this is going to be 20 plus 2 minus 4. So check my work. 20 plus 2, that's 22. Minus 4, that's 18. Okay, at 0, that's the easy one because 0 makes everything go away. These all go away. Your answer is just -4. At 2, 5 times 2 squared minus 2 minus 4, that's going to be 20 minus 2 minus 4. So that's 2 minus 4. So then we get 18 minus 4. So final answer is 14. Okay, so that's it for 5.1. There's your super fun homework. Good luck. Happy studying, and I will see you on the next video.